Welcome to Unit 15, Lesson 1, Misleading Graphs. By the end of this lesson, you'll be able to determine if a graph is well designed or if it contains misleading information. This is a photo of Nathan Zoner. When he was 14, he did a science experiment. He showed a report of deaths caused by a chemical called dihydrogen monoxide, and he asked them whether or not it should be banned. Well, 43 out of 50 of his classmates agreed that yes, they should ban DHMO. He ended up winning first place for his science experiment, which was titled, "How Gullible Are We?" Dihydrogen monoxide is water. They all agreed to ban water. James Glassman of the Washington Post reported on the science experiment and coined the term zonerism to mean the use of a true fact to lead a scientifically and mathematically ignorant public to a false conclusion. Now, we don't want any of you to be part of that group. So it's your job to verify any such claims. When people are presenting information, verify it. Don't be gullible. Say, I don't know, when you don't know. When someone talks in absolutes, always, never, every time, add a question mark to every one of those sentences. Is that really true always? Has that never happened? When someone argues for one side of a conflict, research both sides. Educate yourself. Google everything. And make sure you're Googling respected sources. And admit to yourself that you may not know everything. Learn about your biases. So what's one thing you can learn about today? Well, you can learn about graphs. Data is often presented in graphs. Do you know what to look for in a well-designed graph? It must have a descriptive title. Here we have the carbon dioxide concentration at the Mauna Loa Observatory. We know what we're measuring, where we're measuring it. Labeled axes. We have CO2 concentration in parts per million, and we have years across the bottom. Scales that are easy to interpret. Here we see we're jumping by fives, and we have the individual years in between. Here we're consistently going up by tens. It'll have a key. Some graphs may have different colors, different shapes. Is there a key defining what those represent? And a minimum number of distracting features. Is it clear and easy to follow? Let's look at example number 1. Why is this graph misleading? Religions of the world. Well, if you look at it, it appears as though Muslims are the greatest number, and that's because they used a 3D effect. Okay, the 3D effect distorts the data. If we look at it again without the 3D effect, we can see Christians and Muslims are very close, with there actually being more Christians. This is very similar. Why is this misleading? Again, the volume changes significantly. Instead of just looking at the difference in the height, you're looking at the difference in the volume. And that's because the 3D graphics, again, distort the image. Looking at example number 3, what could possibly be misleading about this graph? It's showing us results by party. Well, if we take a look at the exact same graph starting at 0 instead of 53, this appears like there's a huge difference between Democrats and Republicans and Independents. Where if we look here at the full graph, we see it's a much smaller difference than they're making it appear. So are they trying to influence us by that graph? You need to be asking yourself these questions. What are they trying to sway my opinion one way or another? Why is this graph misleading? Well, when we have a pie chart, that is 1 pi. It should total 100%. If we add 70, 63, and 60, do we get 100%? No. That is very misleading and not mathematically sound. Here, these two graphs below are the same. Why are they misleading? Well, we can see across the bottom axis when we stretch it out, it looks like our graph is increasing much more slowly. Here, this distance from 0 to 5 is different from this distance from 0 to 5, so it's stretched out vertically, so it looks like it's increasing much faster that way. So pay attention to the details. Details are important. Graph number 6, can you find the misleading details in this graph? Let's take a look across the bottom. This segment of time is last year, representing 365 days. This segment of time is last week, representing 7 days, but look how much bigger and longer it is than the first section. And here's representing the currents. This today, this whole length of time is just for today. So your segments need to be consistent in what they're representing. So that scale is off. Now also graphs may have outliers. So we need to look at our data and see, is there possibly something on the graph that may be throwing the data off if we're talking about averages? So let's review. What are possible ways that misleading graphs can represent data incorrectly? They can use biased words in the titles or the labels. They can use cropped graphs or broken axes that make the data appear differently than it would otherwise. Maybe the graphs are not drawn to scale, different segment lengths. You could have misleading pictograms like our pie graph that didn't add to 100%, or 3D pictures that distort the data. And you can have outliers or extreme points in the data that throw information off. Thank you.